So I'm a paleolimnologist, which means I collect sediment from lakes, and I study that sediment to understand changes in hydroclimate, so how precipitation is varying over several thousand years, as well as human impacts to the lake and its watershed. So how have people changed the land around the watershed? How have they changed the sediment input into the lake over the last couple thousand years? Most of the lake cores that I use are collected using hand-powered equipment. The coring method that I use is typically what's called a Livingston core. And so it's kind of a barrel that we put down in the sediment, and we attach long aluminum rods in 1.5 meter sections successively. So we lower it down and we screw another rod on, lower it down, screw another rod on. And then we lock a piston up at the top on our boat, and we push the barrel down as hard as we can. Usually we get a lot of people pushing on the rods, trying to force the sediment through the barrel. And we collect those in 1 meter sections. So once we get 1 meter collected in the rod or in the coring equipment, we pull it all up and we lay it down on the boat, and then we push the sediment out the bottom and put it in a plastic PVC tube that we take back home. And then we do that all over again until we essentially can't push any further, or until we collect the entire sediment record. So usually we can tell we've got the whole record if we see gravel or sand at the bottom, and that indicates that's the formation of the lake. I rely a lot on very basic sediment parameters. So when we get a core back from the field, we bring it to the lab and we open it up. And the first thing I look at is, what does the sediment actually look like? How does it change over what is usually 1 meter or 2 or 3 meters? So are there significant changes in grain size, which may indicate what kind of sediment is washing into the lake? Does the color change? Does the mineral that's present in the sediment change? And so that can tell you a lot about water balance, how the lake levels are going up and down. In terms of geochemical methods, I use a lot of isotopes. So most of the lakes that I work on precipitate carbonate minerals, so calcite, aragonite, those kinds of things. And the oxygen isotopic composition in those minerals archives the lake water oxygen isotopic composition through time. And that can be impacted by changes in either precipitation or changes in evaporation. So how much the lake is evaporating and lowering over time. So if we look at that oxygen isotopic composition down a sediment core, we can then infer how lake levels have changed through time. And so that's a lot of the work that I do in order to understand, get a semi-quantitative understanding of lake level reconstruction. So the work that I do is very relevant to human timescales, because I'm very interested in how lake levels are changing at decadal timescales, right? So things that change on human lifespans. And in particular, I'm interested in lakes where people are relying on these freshwater resources for either agriculture, irrigation, recreation, whatever use they may have for it. So I'm really interested in looking at how those lake levels have changed in relation to human activities. In particular, I'm really interested in how climate change has impacted human activities and how human activities impact climate change, that two-way relationship. And so in lakes, for example, in Peru, these are really essential freshwater resources. And so we're looking at how lake levels have changed and how that's impacted human settlement patterns through time. And that can give us a better perspective on how people might respond to climate change in the future.